All right, guys, I'm going to start by drawing a sketch, labeling it, and S to N is x squared, WO is 9x minus 14, and NO is 2x. So because it is a parallelogram, opposite sides are the same, so I'm going to start with setting my x squared equal to 9x minus 14. Then, because it's a quadratic equation, I'm going to move everything over to the left side. I'm going to subtract my 9x. I'm going to add my 14. And then I'm going to factor. So two numbers that make a product of positive 14 and a sum of negative 9, negative 2, and negative 7. So x equals 2, x equals 7 would both be solutions of my equation. When I come over to my picture to make sure that one or both make sense, or maybe neither of them make sense, if I take 2 and plug it in here, that's going to give me 4, and that's going to give me 4. And it says parallelogram, but not a rhombus, so that's not going to work. Not sure, that's not erasing. And then, oh, here we go. If I take the 7 and plug that in, that's going to give me 49 here and 14 here. So that works. And all it says this time is solve for x. So I'm going to keep x equals 7. All right, in the next picture, this is a rhombus. So I'm going to mark my right angles in the middle. And I know that all of my sides are the same. So what they've given me is expressions for, if I look at this triangle, I can see I have a leg and I have the other leg, and I also know that this has to be 3x plus 7 because all the sides are the same in my rhombus. So I'm going to set up my Pythagorean theorem. So that's going to be x plus 1 the quantity squared plus 4x the quantity squared equals 3x plus 7 the quantity squared. Now I've got to use what we reviewed the other day. I'm using some algebra here. This really just means x plus 1 times x plus 1. This means 4x. Whoops. 4x times 4x. And this is 3x plus 7 times 3x plus 7. So over here, this is going to be x squared plus x plus x plus 1. All right, if I take first and second, first and first, or second and first, second and second. So I'm using my distributive property here. Now, be careful here. 4 times 4 is 16, and x times x is x squared. Over here, if I take 3x times 3x, that's 9x squared plus 21x plus 21x plus 49. Whoa. Sorry about that. Okay, and so when I combine all my like terms, I'm going to end up with, combine your like terms and move everything to one side, I'm going to end up with 8x squared minus 40x minus 48 equals 0. Now, remember, when you're looking at a quadratic equation like this, if the first term is not 1, you want to try to factor if possible. And I can factor. I do have a GCF. I can take 8 out of all of my terms. So when I do that, that leaves me with x squared minus 5x minus 6. And then, of course, I can divide both sides by 8. That gets rid of that. And now I'm just factoring this remaining quadratic. So 2 numbers that make negative 6 when I multiply and negative 5 when I add. Negative 6 times 1, negative 6 plus 1. So this gives me x equals positive 6 and x equals negative 1. Maybe. And so when I go back to my picture and see if either of those work, when I plug 6 back in, it's going to give me nice positive lengths that satisfy the right triangle. If I plug negative 1 back in, that's going to give me when I plug negative 1 back in for the x plus 1, that's going to give me a 0 length, and that does not make sense. So I'm just going to keep positive 6. And it just says solve for x, so I'm finished there. Next problem. It says find the perimeter of SQUA. You can see it's marked as a square. Sides are marked the same. Angles at the corners are right angles. So that means what I'm going to do is focus on one of my right triangles. It does tell me that S to U is 18 centimeters. So that means this whole piece right here, maybe, is 18 centimeters, which means, and the diagonal is split in half. So each one of these would be 9. So I know each piece of my diagonal would be 9. And if I look at this triangle here, for example, I know I have a right angle there because diagonals are perpendicular. And so I can put my x here and set up Pythagorean theorem. 9 squared plus 9 squared equals x squared. So I have 81 plus 81 equals x squared. And this gives me 162. And I can take the square root. And that gives me about 12.7 centimeters. All right, now we're looking at just general parallelograms where opposite sides are the same. So in this particular first problem here, A is just 10 and B is 5. In the next problem, opposite angles are the same. So I'm going to set for x plus 12 equal to 136. And that gives me x equals 31 when I subtract 12 and divide by 4. And then the consecutive angles are supplementary, so W would have to be 44. In letter C, the diagonals bisect each other, so that means that this piece is equal to this piece, and this piece is equal to this piece. So I'm just going to set the expressions equal to each other. For example, 4x plus, oops, that's a minus. 4x minus 3 would equal 7x minus 24. And I would solve for x, and I get x equals 7. I'm going to set the 3r plus 13 equal to the 9r minus 17, and I get r equals 5. Diagonals bisect each other, split each other in half. And number 5, we're dealing with angle measures in a regular or just plain old parallelogram. So because I have 27 here, remember opposite across, so this is also 27. You can do the same thing over here. This has to be 78. Because I have 103 in the middle here, vertical angles, that's 103. Linear pairs, these are both 77. Then I can use triangle sum to figure out a missing angle. 78 and 77 gives me 155, so this has to be 25, which means up here opposite across is also 25. And then 103 plus 27 is 130, so this would have to be 50. And opposite across here has to be 50. So I filled in all my measures based on those properties. Opposite angles are the same, consecutive angles are supplementary. I have triangle sum, I have linear pairs, vertical angles. So make sure you're reading your angles carefully. This is 128, 50, 128, 25, and 77. True, false questions. If a quadrilateral is a rectangle, then it is a parallelogram. That is true. Rectangles live in the parallelogram families. If, whoa. If a quadrilateral is a rhombus, then it is a square. That's false. You can definitely have a rhombus that is not a square. It has to be true all the time. And the diagonals of a rectangle are perpendicular. That is only true if the rectangle happens to be a square, so not true all the time. So that is false. Looking at the properties of special parallelograms, we have rectangle, rhombus, and square. Here we're filling in the missing values. So keep in mind when you have your rectangle, you're going to mark your right angles in the corners. And you have a bunch of isosceles triangles. 65, 50, 65, 25, and then E is asking for the length of this, and you've got opposite sides that you're going to set equal to each other, so E is 11. In the rhombus, you're going to mark your right angles in the middle, and all of your sides here are the same. Remember, the diagonals also split each vertex angle in half, so that's 26, and these are 26. And because I have 26 and 90, I know my other remaining angle is 64 degrees here. And all four of those are the same. So I have A is asking for a length, which is 7 inches. And I have 90. Whoa. $26, 64, and 64. Rectangle again here. Right angles in the corners. A bunch of isosceles triangles. Diagonals are exactly the same length. So 12 meters, 128, 26, 26, 26, and 16 meters. In my square, remember I got a ton of right angles, 90-degree angles, 45-degree angles. Sides that match, diagonals are exactly the same and split in half. So here I have 45, 45, 17 inches, 90 degrees. And for E, this is where you have to set up your Pythagorean theorem. Again, I do know the side length is 17. So if this is E, so is this. So I can do E squared plus E squared equals 17 squared. Because remember, I do have right angles in the middle there. So I have a right triangle. So when you solve here, you end up with 12.02 inches. Now, for the remaining 3 problems, these are, you want to draw a sketch, label your vertices, check your slopes, your lengths, and possibly your midpoints if you're using that method for number 11. So that you can check the answers for that one. I have the pictures drawn out. So hopefully that helps. And if you have any questions, you can shoot me an email. Check the answer key on Schoology for the rest of those pictures to look at. Hope you had a great day.